Hello friends, today we are going to start with quadratic equations. So basically we will understand what are quadratic equations and then we will proceed to solving the quadratic equations, right? An equation in the form of ax square plus bx plus c equal to 0, it is called a quadratic. In this equation a, b and c are constants and the condition is that a is not equal to 0. Now why a is not equal to 0? If a is equal to 0, then this would become bx plus c equal to 0 and then that would become a linear equation. It would no longer remain a quadratic equation, correct? So a is not equal to 0 is one important condition over here. Now let's start solving quadratic equations. Now what are the methods? Methods of solving quadratic equation would be factorization, then it would be completing square, or then you can use quadratic formula. Okay, so we are going to see these methods of solving a quadratic equation one by one. Let us start with factorization. Now how do we do that? There is certain procedure, but then let us understand the logic or the thought process behind that. Okay, now when I have something like this, I write that a multiplied by b is equal to 0. Now when do I get this product of a and b equal to 0? Either a has to be 0 or then b has to be equal to 0, or then a and b both have to be equal to 0, isn't it? So likewise, if I have something like this, if I write here x plus a multiplied by x plus b is equal to 0. Now in this case, either x plus a should be equal to 0 or x plus b should be equal to 0, or x plus a and x plus b both have to be equal to 0. In that case, in the third case, it would mean that x plus a equal to x plus b equal to 0, isn't it? So in that case, a and b will have to be equal to 0, correct? So now if I expand this, okay, what I get here? I get x square plus ax plus bx plus ab equal to 0, and further to that, what I get is x square plus a plus b multiplied by x plus ab equal to 0. Now if I put a equal to 1, a plus b equal to b, and ab equal to c, then I can write this equation as ax square plus bx plus c equal to 0. And is it not the same form here, right? My equation ax square plus bx plus c is a quadratic equation, and now from this logic we will proceed towards solving it by factorization. So for solving by factorization, what I am going to do is I am going to split this third term, this term ab, in two factors. Now in this case the factors are a and b, okay, such that the middle term, the coefficient of the middle term, coefficient of x, it is the sum of the factors of the third term, okay, and that is how we are going to solve equations by factorization. So let us take an example. X square is equal to 5x plus 6. Now here on my right hand side I have 5x plus 6, but then I have to take it in this form. So I'll write x square minus 5x minus 6 equal to 0. Now what I'm going to do is I'm going to factorize this constant term, third term. Now this is minus 6, correct, and here I have minus 5. Okay, so minus 6 is equal to minus 1 into 6, so it would be minus 1 multiplied by plus 6, okay, or then it is equal to 1 multiplied by minus 6. Now if you compare these two, minus 1 plus 6 is plus 5, but 1 plus 1 multiplied by minus 6 is minus 5, and I have minus 5 here, correct. So I'll write it as x square plus x minus 6x minus 6 equal to 0. Now I take x common here, x multiplied by x plus 1 minus 6 multiplied by x plus 1 equal to 0. Now I take x plus 1 common, so x plus 1 multiplied by x minus 6 equal to 0. Now x plus 1 multiplied by x minus 6 equal to 0, it means that either this part has to be 0 or this part has to be 0. So I'll just write it here, x plus 1 equal to 0 or x minus 6 equal to 0, and then that gives me x is equal to minus 1 or x is equal to 6. Now you may try substituting x equal to minus 1 and x equal to 6 in this equation, correct. Now if you put x equal to minus 1, then minus 1 square is equal to plus 1, and that should be equal to 5 into minus 1 plus 6. So minus 5 plus 6 is equal to 1. So 1 is equal to 1. So yes, this value is satisfying my equation. And if I put x is equal to 6, now I put it over here. So x square, so 6 square is 36. That is my left hand side. And right hand side is equal to 5 into 6, that is 30 plus 6, and that is equal to 36. These two values of x which satisfy the given quadratic equation, they are called roots of quadratic equation. Okay, this is how we solve quadratic equations by factorizing. I'll be giving a few more practice problems for you to solve, but then for now we will go to this method of completing square. So let us go to completing square, solving a quadratic equation by completing square. Let me take one example here. I write x square plus 4x plus 1 equal to 0. Okay, now I'm going to complete square, but then how can I do that? I'll take this constant term on the other side. Okay, so I write here x square plus 4x is equal to minus 1. Okay, now here I have x square plus 4x. So how can I make a complete square out of it? What I'll do is I'll add x square plus 4x plus 2 square, and then that would be equal to minus 1 plus 2 square. I'm adding 2 square on both the sides because I'm not allowed to change the equation itself. If I don't add 2 square here, then the whole equation will change. Okay, and we are not allowed to do that. Now here I can write it as x plus 2 whole square, and this is nothing but minus 1 plus 4, that is 3. Minus 1 plus 4 is plus 3, correct. Now I take square roots on both sides. Okay, so I can write x plus 2 is equal to square root of 3, but then there will be two square roots for 3. One would be positive square root and the other would be negative, so plus or minus root 3, correct. So my x plus 2 is equal to plus root 3, or x plus 2 is equal to minus root 3. So my x would be equal to minus 2 plus root 3, or x would be equal to minus 2 minus root 3. This is how we solve quadratic equations by completing squares. So now, having seen the two methods, method by factorization and solving by completing the square, let us come to the third one, that is quadratic formula. Now here we are going to have a generalized formula. You can apply that formula to any quadratic equation and get your answers. You can solve any quadratic equation by that. Now my quadratic equation is ax square plus bx plus c equal to 0. Okay, let us see how we do it. Now obviously my a is not equal to 0. So can I divide both the sides by a? Yes, I can. Had a been equal to 0, I would not have been able to do that. But then in that case, my it wouldn't have been a quadratic equation. It is a quadratic equation just because my a is not equal to 0, correct? So now I'm dividing both the sides by a, so I'm left with x square here plus b upon a into x plus c upon a equal to 0. Okay, we are going to use method of completing squares here. Okay, so I'm going to put this constant term on the other side. So x square plus b upon a into x is equal to minus c upon a. Okay, so now let us complete the squares here. Okay, so what do you do here? For completing the square, you have to add b upon 2a square here and b upon 2a square here. Okay, so that this would become x plus b upon 2a whole square is equal to minus c upon a plus b square upon 4a square, correct? Now if I want to make the denominator for both of them common, that is 4a square, so 4, I'll multiply the denominator by 4 and another a, so I am multiplying by 4a. So in the numerator as well I will have to multiply by 4a into 4a here, correct? So then that makes it b square minus 4ac upon 2a whole square, isn't it? So this is x plus b upon 2a whole square is equal to b square minus 4ac upon 2a whole square. Okay, so now let us take square roots on both the sides. It gives me x plus b upon 2a is equal to, now see it is square root, I am taking square root, right? So it is going to be plus or minus root of b square minus 4ac, and for this it would be only 2a. Now I take this b minus b upon 2a on the other side, so it gives me x is equal to minus b plus or minus root over b square minus 4ac upon 2a. So my x is going to take, one value would be minus b plus root over b square minus 4ac upon 2a, and the other value is going to be minus b minus root over b square minus 4ac upon 2a. Okay, so that gives me two roots of any quadratic equation. So now maybe if you try using try solving this equation, the equation which we used in the earlier problem where we tried factorizing. So over there x square minus 5x minus 6 equal to 0. Okay, so now here my a is equal to 1, b is equal to minus 5 and c is equal to minus 6. So if I substitute these values in this solution, my x would be equal to minus b. Okay, so minus of minus 5, so that would be 5 plus or minus root over b square, so that is 25 minus 4 into a into c. Now minus 4 into 1, that is minus 4, and minus 4 into minus 6, it is going to be plus 24 here, and that divided by 2 into 2a, and my a is equal to 1. So this gives me how much? 25 plus 24 is 49, and square root of that is plus or it is equal to 7. So it would be 5 plus or minus 7 divided by 2. So that would be equal to 5 plus 7 is 12. 12 upon 2 is 6, or 5 minus 7 is minus 2, minus 2 upon 2 is minus 1. Isn't that what we found as an as answer over there in the earlier problem? Yes, it is. So you can apply this quadratic formula to any given quadratic equation and you can get your answers. Now there is one thing. This is under root b square minus 4ac. You know what is that called? It is called discriminant of quadratic equation. Okay, I call it if I call it delta. Okay, delta is equal to b square minus 4ac. If it is greater than 0, fine. Okay, we can find out square roots of any positive numbers, right? But what if my b square minus 4ac is less than 0? Then that would be square root of a negative number, and then square root of negative number, so that would involve complex numbers, isn't it? Imaginary numbers. So we could say that if my discriminant is less than 0, then the roots will be imaginary. But if my b square minus 4ac, if it is greater than 0, then I will have two roots. The roots will be real and distinct. Okay, distinct. What if b square minus 4ac equal to 0? In that case, my both the roots are going to be minus b upon 2a. So that means the roots will be real and equal. Correct. Why real? Because a and b and c, of course, they are real numbers and my discriminant is 0. So my this quantity under the square root, okay, that second quantity is going to be equal to 0. So I get real and equal roots in this case, right? So that is how we solve quadratic equations. You are going to get a few exercises to solve, in the description. Thank you so much.